Task number 4, IP addresses and subnets. When you hear the word IP address, you might think of an address like 192.168.0.1 or something less common such as this one. In both cases, you are right. Both of these are IP addresses, IPv4 addresses. Every host on the network needs a unique identifier for other hosts to communicate with. In other words, every device that uses the internet or via cable or Wi-Fi needs an IP address. It's basically every home in the world needs an address, a number. Without a unique identifier, the host cannot be found without ambiguity. When using the TCP/IP protocol suite, we need to assign an IP address for each device connected to the network. One analogy of an IP address is your home postal address. Your postal address allows you to receive letters and parcels from all over the world. Furthermore, it can identify your home without ambiguity, otherwise you cannot shop online. As you might already know, we have an IP address v4 and v6. IPv4 is still the most common, and whenever you come across a text mentioned IP without a version, we expect them to mean IPv4. So, what makes an IP address? An IP address comprises 4 octets, that is 32 bits. Being 8 bits, an octet allows us to represent a decimal number between 0 and 255. An IP address is shown in the image below. This IP address, right, represents one device. One number represents one octet. Here again, 4 octets, 8 bits, from 0 to 255. At the risk of oversimplifying things, the 0 and 255 are served from the network and broadcast addresses, respectively. In other words, 192.168.1.0 is the network address, while the same one with 1 and 255 is the broadcast address. Sending to the broadcast address targets all the hosts on the network. With simple math, you can conclude that we cannot have more than 4 billion unique IPv4 addresses. If you're curious about the math, it is approximately 2 to 32 to the power of 32 because we have 32 bits. This number is approximately because we didn't consider network and broadcast addresses. Right, so basically in very, very, very simple to understand, an IP address is just a unique address of a device, of a host on a network. Any device you use, internet, has a unique IP on the network in order to be identified on the network. When you make requests, when you make payments, when you make whatever on the network, you need this one. This IP address, which is unique to everyone. It's like the number of your car. It's like the number of your house. They are unique, like the IP on your PC. Looking up your network configuration, you can look up your IP address on the Microsoft Windows command line using the command ipconfig. On Linux and Unix-based systems, you can issue the command ifconfig or IP address show, which can be typed as IPAS. In the terminal below, we show the ipconfig. Yeah, so basically we see the output of this command. The terminal output above indicates the following: the host, which is the laptop IP address, here, IPv6, this one is the IPv6 version 6. The subnet mask, basically to the right of the IP, and then we have the broadcast. Let's use the IP AS, and then you can see almost the same thing, right? The terminal output above indicates the following: the host, the laptop host, and then the broadcast IP address, and then the subnet mask. If you are wondering, a subnet mask of this can also be written as forward -24. The forward slash means that the leftmost 24 bits within the IP address do not change across the network, that is the subnet. In other words, the leftmost 3 octets are the same across the whole subnet. Therefore, we can expect to find addresses that ranges from over here to 254. The first 3 octets will be the same. Similar to what we mentioned earlier. So basically, again, when we see the last octet to the last one to the right. Private addresses. As we are explaining IP address, it is useful to mention that for most practical purposes, there are 2 types of IP addresses, public ones and private ones. RFC 1980 defines the following 3 ranges of private IP addresses. And you can see them over here, the 3 private addresses. We presented earlier an analogy starting that a public IP address is like your home postal address. A private IP address is different. The original idea is that it cannot reach or be reached from the outside world. It is like an isolated city or a compound where all houses and apartments are numbered systematically and can easily exchange mail with each other, but not with the outside world. For a private IP address to access the internet, the router must have a public IP address and must support network address translation, NAT. At this stage, let's not worry about understanding how NAT works, as we will revisit it later in the module. Before moving on, I recommend memorizing the private IP address ranges. Otherwise, you might see an IP address such as this one or this one and try to access it from your public IP address. So we go to routing. A router is like your local post office. Now, routers are absolutely everywhere, basically. You use a router. If you have internet at home, basically you have a router. You hand them to mail parcels, and they would know how to deliver it. Yeah, so basically they try to make an analogy of what a router is. When you make a request from your PC, basically the router deals with finding the route and then just searching on the destination. But let's read on, and then you will have a bigger picture. If you dig deeper, you might mail something to an address in another city or a country. The post office will check the address and decides where to send it next. For example, if it is to leave the country, we expect one central office to handle all shipments abroad. In technical terms, a router forwards data packets to the proper network. Usually a data packet passes through multiple routers before it reaches its final destination. The router functions as layer 3, inspecting the IP address and forwarding the packet to the best network router, so the packet gets closer to its destination. We see here, for instance, a laptop user, an office user, desktop user, and then the web server. So let's say this here is the destination, and here is the initialization of the call. So we call a web page from a mobile user or office user, but the web page or the website that we call lives here. And you can see here how many routers we have, and this is a potential path Everywhere on this map is a potential path to our call, our request to reach the server and then back to us. Answer the questions below. Which of the following IP addresses is not a private address? If we go over here, you can see here all the private addresses, right? And you can see here, this is a clue, the first 2 octets. If you go back here, you can see this one is there, this one is there, and you can see that this one, and this one. So this one is not 49, 69, 147, 197. Which of the IP is not a valid IP address? Let's see. This one. 192.168.305.19. Cool.